Uh, Good morning, everyone. Welcome to the latest FS webinar series. Today, we're going to be talking about how we modernize applications. I think previously we've looked at how FS companies adopt new platforms and move in an agile way to deliver innovation fast by adopting those technologies. Today, we're going to look at an alternative way of how a bank can, modernize within their existing application stack. So today, we're joined today with Head of Cloud from CSI, Jason Normanton, and Paul Chapman from IBM. Paul, Paul's work. I don't know if you would you like to do your introductions, Paul? That'd be great.
Yeah, sure. Hi, Matthew. Everybody, it's a pleasure to work with CSI. Thanks for inviting me today. I've spent 12 years working for 3 IBM business partners before joining IBM, and then once in IBM I spent a couple of years in professional service, then 10 years in technical pre-sales. I took a year out in 2014 to work directly for America's largest bank, where I concentrated on architecture and strategy for the Power Enterprise Cloud.
Hi, Matthew. Good to be here on the FS network again. My name's Jason Normanton. I'm here today to provide some background around what we do with cloud and just help Paul, our IBM business partner, to talk about the modernization story that he's going through currently.
Yeah, thank you, Jason. Paul, why don't you tell us? How does the FS sort of sector fit with IBM? Just give a little sort of background to that. That would be ideal to start.
Yeah, sure. So IBM has always had a valued and a very strong relationship with the finance sector. I've certainly spent much of my time working with banks and finance companies. Most companies actually touch IBM technology, whether that be mainframe, power, storage or software.
Okay. As digital transformation seems to be a hot topic of the decade, in your experience, what is on their agenda today? What are you seeing in your sphere?
Yeah, so looking back on the way it's grown, I recall banks starting to build on-premise cloud-native solutions 6 or 7 years ago. Of course, that was very much early adoption and research. These activities have led to much more mature and enterprise-ready solutions like Red Hat Openshift today. I know banks that have scaled from nothing to 20,000 containers in just 4 years, and others have OpenShift clusters with over 1,000 nodes. But when customers scale at this rate, they really need a complete suite of integrated systems management tools, which you get with Red Hat OpenShift. Infrastructure reliability and availability becomes much more important as customers place critical workloads on growing clusters.
I think you're exactly right, Paul. The customers that we speak to, these systems are absolutely the lifeblood of their business. With these growing in size, how does IBM help their customers achieve the desired outcomes that they're looking for around modernization?
Yeah, that's a great question. So IBM helps by providing the most reliable and highest performing systems, increasing availability, reducing risk, cost, available in a pay-per-use model, whether that be public or private cloud. There's no doubt the recent pandemic has increased the rate of digital transformation massively. Banks have needed to cope with much more online activity as branches have had to close and people have used contactless payment much more and more. So IDC have provided a webinar which is available as a replay along with IBM. I'm sure the slides from this will be made available, and you can actually watch the replay for much more detail on that.
Excellent. So is there any chance you could possibly show us an example of where this kind of transformation's taken place, Paul? Yeah,
sure. But perhaps just before I do that, perhaps we can think about the different options of application modernization. So if we look at this screen, there's two routes for taking an application and modernizing it, plus obviously a third route when you go into a greenfield site and you've got a new application. Over on the right-hand side, as many new workloads are developed today, they come straight in as cloud-native applications from the start, and that's relatively easy to do. Developers have grown up that way now, so that they're very comfortable with that. Still, it's generally accepted that only 20% of existing enterprise workloads move to public cloud. The remaining 80% can be much more challenging. You can certainly refactor the existing data-centric workloads, but this takes considerable time, resource, budget, increases cost, so it can be far more efficient to actually modernize these workloads by simply surrounding them with microservices. This provides the benefits of cloud native quickly and at reduced cost. So if I just shut this down and share a screen, we can perhaps look at a live demo. And of course, they always say don't do live demos, right? So here goes. So the demonstration that I can show you today is based on, it's not a real live application, let's make that clear, it's a scenario, but it's based on an online banking application. And this is the traditional user interface that's maybe been around for quite some time. It's just through a browser.
Paul, I think we're still looking at the presentation.
Right, okay, let me just
sorry to interrupt.
Reshare. On application, I thought it was sharing the screen.
There we go.
Okay,
yeah.
Great. Okay, apologies for that.
That's right.
So yes, this is just a browser user interface, and it shows the traditional user interface into the online banking application. Now, this is actually the front end of a two-tier application using DB2 as an online database at the back end. It uses WebSphere application server, and this is all residing on a power system here. This is the hardware management console. So we can see there's two servers. Mobile banking application is actually residing on this server here. And there is usually just 3 applications on here, but we're actually just building another demonstration at present. So if I just consolidate that down, this is our DB2 database. And we look down, this is the WebSphere application, LPAR. Now, these are both traditional virtual machines. IBM call it LPARs, logical functions. Now, they are sitting on just that one server. This is the traditional user interface that accesses it. And I can log in here. Right, okay. And from here, you know, we get some basic functionality. So we can look at account balances. We can see this particularly as 4 accounts, and perhaps we can deposit some money, or we can actually withdraw some money, and we have that kind of functionality. We can go back and look at the transaction history and give you that kind of information. Now, if I log out of that, the traditional access point, this is the modernized interface to the same data. Now, we haven't actually moved that data. It's still sitting on that DB2 database. And actually, WebSphere application server is still sitting there. And you know, the reasons for this is it would take time, effort, money, resource to actually move that anywhere. And there's really not a lot of need to, because it's actually providing a very mature and stable platform. It's been serving users for a considerable amount of time. It's stable. What we've actually done here is installed an Openshift cluster on the very same power system. It's the same server that's running the traditional workload. And if I go back to the hardware management,
just for those of our, of our audience who aren't aware with what Openshift is, Paul, so that provides them with a container environment where they can put additional application components. Is that fair to say?
Yeah. So Openshift is a platform in essence. Some people think of it as an application or a workload. It's not. It's actually a platform for hosting those workloads. And when you install it, you install some master nodes, which provides the main infrastructure, and then you can dynamically add worker nodes, which are the the system which actually you then install and run applications on. Now, there's lots and lots of reasons why this is beneficial. You can cater for auto scaling. So with microservices, we tend to run multiple pods or containers, and the system knows exactly what's going on these pods, containers, and which nodes they run on, so they can form a scale out architecture. Now, the benefit here is that if it's actually running, say, the same application across 3 containers and 3 pods across 3 physical servers, then should one of those servers go down, the HA proxy still has the application up and running across the other 2. And OpenShift, as the platform, can then just actually start another container or pod to cater for the workload utilization required. So it fixes problems on its own, right? Also, if you were to perform an upgrade, it's not an upgrade in the traditional sense that you take a monolithic application and you have to take some downtime to actually change the code. In this instance, you literally do create another container, which can be done in seconds or a minute, and it comes online with the new version of code, and then you just disable one of the old pods. So it's kind of bring in the new and take out the old. It reduces downtime.
But in this instance, what we're saying is it's all sitting on one server, so it's a very simple enablement of new features. That is obviously if it was going more for larger production, but it can all run on the same server as the DB2 database if you have that capacity as well.
Yeah, and that's really important, Jason, because we've had some customers or development teams perhaps that aren't particularly familiar with Power Auto, and when they look at the application, they might look at WebSphere and say, okay, we're going to create this in a more agile manner, maybe using continuous integration and development. They want to get all the benefits that they do, the new way of programming. And you know, you can choose to put that across, and this demonstration actually shows it. You can put that across any public cloud and integrate it with OpenShift. But the benefits that our customers see when they put those microservices on the same physical server where the data resides, you know, it's not going through multiple firewalls or between different clouds. It just increases network performance, which has an end result, meaning the application is far more efficient. So actually co-locating OpenShift containers on the same server that runs the traditional LPARs or virtual machines has great benefits to everybody concerned.
Excellent. Thank you, Paul. I'll let you get back to your demo.
Yeah, sure. So I think looking at this is where we said that the original DB2 and WebSphere application server LPARs were residing. And now if I look, OpenShift, you run the infrastructure on master nodes, and that's quite important too, because you don't pay for any software licensing or anything on the infrastructure itself. So when you keep these in separate virtual machines, then you don't have to pay for the license for them. Now, traditionally in an OpenShift cluster, you have 3 masters. We've actually got some more here because we're actually building another OpenShift cluster on this system at the moment. And we can also see the worker nodes. And this is where you have that scale out architecture. So that is on that OpenShift cluster is actually where this new modernized user interface is actually residing. And in some ways, I think this is just a demonstration when we say this is modernized. Okay, they've made it look a bit prettier, a little bit more modern or so, but that's not where the key advantages comes from. The key advantages are being able to apply updates without any downtime, continuous delivery. The advantage of being able to deliver new services without affecting the existing services from the original application. So let's take a look at that. If I log in, I'll log in up with the same user 11. And again, we have the basic account summary. So that the user had four accounts. We can look at the transaction history. We can see that, you know, just made these 2 transactions, which kind of shows that the traditional user interface and the new modernized one is actually accessing the same data. Now, if I log out from there, so the whole point about delivering this modernized application wasn't so it looked prettier. It was for the line of business, because, you know, IT is there to serve the business, right? And the line of business in this case, let's take a trip back in time, go back to February or March of last year, and, you know, COVID-19 having an impact all over the world. People are unable to travel. Incomes may have been lost because they can't go to work, etc. And, you know, a key thing for this type of offering is to bring new services to market first, because that's where businesses get competitive advantage from their competitors, right? So in this instance, the line of business actually wants to implement a new service for its customers. They wouldn't be the bank that cares, right? So they want to implement a new service whereby customers request maybe a payment holiday for their overdraft, or maybe their credit card bills or something rather like that, because they're recognizing that, you know, some customers struggle. Maybe they've received some, you know, some help from the government also to provide this service even. So in that case, using the new way of delivering services, the bank is able to put a very small team, maybe 2 or 3 developers together, to create a very simple additional service. And in this case, that is the request for payment holiday. We look here, the 3 sort of applications that I'm going to talk about today are all the yellow items in the menu. And if we click on the COVID-19 action there, what we actually find is that we get another tab on our browser appear. And this is where the customer can actually put in their details to actually request that payment holiday. Now, I mean, it could be anywhere. We've said that the Openshift cluster is running on the same physical server that the traditional data and user interface originated from. In this instance, for whatever reason, they've decided to actually implement this service in Microsoft Azure, because you can do that with, you know, gone are the day really when everybody says cloud first and everything must go to cloud. You know, people generally, you know, feel now that everybody's going to live in a hybrid world, and you're going to have multiple clouds, and that they all need to come together and be managed together. So in this instance, for whatever reason, could be security, could be economics, could be performance, they've decided to deploy this part of the application on Microsoft Azure. And now the lines of business are very pleased, because if they had done this on a monolithic application, then maybe they would have had to have updated that whole Web3 application server. Whereas in this case, they haven't. They've just taken the 2 developers, created a small application, moved that into the main application with continuous integration and delivery, and the service is online. They've been able to do this all very quickly without any downtime. Now, they start wondering to themselves, okay, so this is a great system, but how do we know it's working well? We need to get some customer feedback. So they say, okay, well, we can do the same thing again. And if we look at the second yellow item on the menu, you can see customer survey. So what they do is they take another small team to create another additional feature function within the application. And if we click on the customer survey, then this gives customers the option of saying perhaps how easy it was to request that payment holiday, or to use the service, or did they have any trouble doing so. So now the customer is able to get that feedback from their customers. And if it's good feedback, great. But if it's bad feedback, even better, because now they can do something about it. And if you can change, you know, poor, you know, impressions, then that's even more valuable. So in this case, this has actually been deployed in Amazon Web Services in a containerized solution. So now we have AWS and Microsoft Azure all integrated with our Openshift cluster sitting on our original power system, DB2 and WAS on premises, working nicely. So the line of business not only have developed and provided new services to their customers very quickly without downtime, but now they've now got feedback to demonstrate to the board what a great job they're doing. Now, they think on it a little bit more and say, well, what else can we do? How can we improve it? And they say, well, actually, a number of websites that we visit these days, a whole bunch have chatbots or assistants online to help. So they say, okay, well, we could use the same sort of thing. Again, they take another couple of developers, totally isolated from the two previous service functions I've mentioned, or the original application, and they send them off to make a chatbot or an assistant on the banking application. So if we click on the chat with us, might need to move this over, but now we can see that we've integrated a chatbot which has been created using Watson, this time on IBM Client Cloud. So now we're looking at 3 public clouds plus the on-premises cloud on our systems already. And here we can, talk to the chatbot or integrate with them. We can say, well, we want to pay our credit card, and say, okay, well, we know what the balance is now because we're talking to that data in DB2 in this case. Do you want to pay that now? Yes. Okay. We can get the authentication services built into it. So now we actually give them the passcode to actually perform that, and now we know that the credit card's been paid online without having to phone up or go through any IPR system, or using the original OpenShift system sitting on the bank's on-premise power system integrated with AWS, Azure, and IBM Cloud. Now we've got 3 public clouds essentially, all integrated very nicely and easily with our OpenShift cluster, which resides on premise. In this case, we're using an IBM Cloud Pack for MultiCloud Manager, which is an umbrella really of software products for managing hybrid multi-clouds. And I can show you that pretty briefly here. But what this allows us to do is we can actually manage the virtual machine or the LPARs on the power systems residing on premise. And here, hopefully, in a second or two, we'll see the 2 virtual machines. We've got the Megabank, the Web3 application server here, which we could drill down into, get more information, or start and stop, or manage in that way. And then, of course, the DB2 database too. So that's the virtual machines. But we can actually also gain access and information for the various clusters. Okay, so I can show you the OpenShift and the cluster involved here as well. We go to Automate Infrastructure and Clusters this time. So here we can see 4 different containerized solutions clusters. We can see the Megabank chatbot here. So this is obviously the Watson service in IBM Cloud. And if we look on the right-hand side, we can see that's all labeled up as IBM Cloud 2. The next one down is Azure. So this was the COVID-19, where customers could request a payment holiday, for instance, all running in Azure. AWS, which was running the customer satisfaction survey, and also the original OpenShift cluster, which is running the modernized application and integrates with the Web3 application server and at the back end.
Paul, just a quick one. Obviously, using OpenShift as the main element of this, it's not limited to just DB2 scenarios, is it? It could work with, SQL or Oracle or whatever backend data source you've got.
Yeah, that's quite right. Thanks for sort of making that point, Jason. If I pop in Yeah, I think, you know, once I described OpenShift as being that platform, really, but from day one, in that platform, you have a whole bunch of containers available to you. So you don't even have to go out and install software anymore. You just say, I want this container, and it will deploy that image for you in a very, very short amount of time. Now, just a couple of examples. Red Hat has a container catalog, if you like. So from within OpenShift, you can just search and say, okay, I want IBM MQ, or I want Red Hat AMQ, or JBoss, or any of these kind of open source types. And if you look under Power, you will find 938 certified containers available there instantly for you. As soon as you've deployed OpenShift, then you can just search and put MariaDB, you know, all these kind of technologies, not only open source, but actually, you know, ISVs as well. So this is all available to you straight away. You don't need skills as to how to install it, because the system actually does that for you. And it runs Core OS. So it's a cut down operating system based on RHEL, Red Hat Enterprise Linux. But it's cut down, so it's only got what it needs. Therefore, it's very, very secure. I mean, OpenShift, I think, are the market leaders for this kind of containerized platform. But they're also the leaders in the security side of in containers. Now, when I said that these were certified containers available from Red Hat, that's because the software vendor and Red Hat have been through and certified that that container is safe, or, you know, secure, or performant. You know, they're willing to put their neck on the chopper for it. You know, they've certified it. That's good. You go off to something like Docker Hub and do the same search on Power Systems, then you get just short of 9,000 different images that you can actually tap into straight away. And it doesn't stop there, because you can tell OpenShift to go and install a project from, say, GitHub. So you can have your own GitHub repository. And actually, when you tell OpenShift to attach to this URL for GitHub, then it would actually go through a process called source to image. And it would actually build the container on the fly for you there and then, using the code available. So, you know, potential is endless, essentially, when it comes down to different a software that you can deploy very quickly and manage.
Absolutely, absolutely.
Yeah. So does that make sense? I mean, how do you feel, Jason? What are you doing yourself with?
Yeah, I mean, you know, here at CSI, we've got a real investment in OpenShift, as you well know, Paul. You know, that's been going on for several years now. Most recently, we've started automating environments for some of our more complex customers who, you know, work in the space where they maybe need a test environment on some expensive power hardware, or they only need it for a short period of time. And we've automated the complete build out of those environments so that we can provide them for those test cycles, or for the customer's short-term needs whilst they're upgrading, or even for long-term managed service. We see this as an integral part of the modernization of our business moving forward. And it gives us the ability to basically write one set of code that we can then take to any cloud that we want to work in, with very minimal modification to the actual design. Usually a couple of things around security that are just where the different clouds do things slightly differently. But it gives us very portable code, an extremely powerful IP that we can give to our customers to enhance the services that we provide to them and make things more stable.
Yeah, that's good. It's interesting, isn't it? Because, I mean, you have different options available to you when you start offering this within a managed service. You know, I've worked with quite a few managed service providers, and, you know, you can choose to offer maybe the microservices themselves, so that a client can come in and access maybe those containers individually. or else, you know, some enterprises will actually want a higher level of control over the cluster themselves. So almost then you can offer maybe the infrastructure as a service element and give them control over the entire cluster to do as they wish.
You know, we see that as a very powerful business model, especially when we tie that to something like power. Even if the customer doesn't actually have power, the fact that you can run Linux, Unix, and power containers on that infrastructure gives us flexibility. But the greatest driver, if I'm honest, for us to put OpenShift onto power was more around leveraging power's amazing uptime that's built into the platform. So, you know, we don't get hardware failures. We place it within our key data centers that have high-speed interconnects. And by keeping the control plane within that high availability sphere, we can then bring in other clouds without fear that anything's going to take down our central control system. And we provide that out as software as a service to clients where they feel that they don't want to maintain that or they don't have access to that high availability platform.
Yeah, it's key, isn't it? I mean, a number of customers have been running, well, the traditional way, maybe a two or a three-tier application that we've been deploying for the last 20 odd years served us very well.
Yeah.
And power's been very significant in looking after critical systems because of the availability, but also the performance-wise. You know, when software is charged on a per core basis, then this is able to reduce costs so very much. But what we're finding now is that if you're building a cloud native application, then you have these containerized or microservices available to you, and you know, you can go to AWS or Azure or IBM Cloud or wherever. What we're now seeing is this allows you actually to put it on your, you know, stable and available on-premises hardware as well, which can be, in a lot of ways, can be more economical in that fact.
I think the other thing, sorry for jumping in here, Paul, but I think the other thing that it provides as well is it provides you with a level of flexibility. I mean, we all know that sometimes you can't actually modernize because you're relying on an ISV, for example, to, you know, to provide you with an updated version of the software, or, you know, it's not quite the architecture that you require to move forward, but your software vendor doesn't seem to be coming up with those upgrades quickly enough. By taking this approach, we've found that you can modernize at your own speed without affecting the core package, and you're not, you know, having to reinvest in the complete stack. Because, you know, if I'm totally honest, I don't see a lot of digital transformation of existing software. It's usually a completely new version that moves from a monolithic architecture to a microservices architecture. And I think this is the for want of a term, the hybrid application approach, where, you know, the back end is a traditional platform that serves you well, but is not necessarily so innovative. But you can build with Grafana, Kibana, Elasticsearch, all those open source favorites that we all know and know the look and feel of, but you can get those into your application modernization journey without waiting for the ISV to catch up. Would you say that's fair?
Yeah, I totally agree with you, Jason. I mean, if we go back to the slide which I showed earlier on, if you're going to start from, you know, from fresh, it's easy to go building a cloud native application, and that's what this shows on the right hand side, net new application. But if we've got our traditional application on the left hand side, you know, the first option at the top here is something like HCL Commerce. Now, HCL Commerce, their latest version of code is available in containers, but the amount of effort to get that whole ISV application to that state is a significant piece of work, and it takes, we're indicating here, maybe, you know, in that kind of environment, maybe 12 or 18 months plus type of thing. Now that just puts it into containers. If you're going to refactor into, you know, complete microservices, then maybe you're looking at 2 years plus. And just think about how many enterprise applications and workloads are actually out there already. You know, I think when customer architects look at their current estate, you look for your low-hanging fruit, don't you? You look to see what you can do first. So if there's any of the new stuff, it's easy to go over there and you can do cloud native. What I think some of our customers are missing a trick on is that if we don't look to refactor the entire application or wait for the ISV to do that, then we can still modernize it just by putting something like OpenShift on the very same server. And then, you know, as time moves on, then the ISVs will provide more and more. And, you know, here's an example of one. HCL Commerce has done it, and that runs on Power and x86, various clouds. We're also working with IBM vendors and a number of ISVs to do that, but it's going to take time. And I think if we want to get the, you know, the fastest return on investment, or we want to modernize our whole suite, then you know, deploying something like OpenShift and surrounding the data-centric workloads with containers is a really good way of doing it.
Excellent, Paul.
So, I mean, another thing perhaps I'll mention now is we are working with, well, actually, I mean, IBM and Red Hat work very, very closely together, obviously. And this, from what I mentioned, the financial webinar that I mentioned earlier on, Bruce Anthony is one of our distinguished engineers, which leads a team of people working directly with Red Hat. Now, we have around 50 software engineers actually working as Red Hat engineers, right? And we're there making sure that OpenShift and all the additional features and functions come on are available on our platform straight away in all our cloud packs as IBM moves all of IBM software containerized. But what we're doing at the moment with Red Hat, more specific perhaps for this webinar, is we're working with 4 reference architectures for the banking industry. In actual fact, we have solutions here for real-time payments, anti-money laundering, pricing, risk analytics, and open banking. And we've been working with Red Hat for a little while on this, and we expect to GA and to make all this available in the second half of this year. So and I know a lot of people have actually approached us looking for more information on this, or maybe looking to get involved in betas or early adoption, and so on. So it's worth mentioning that for anybody that's interested in working with us on that through the second half of this year.
Absolutely. You know, if anybody is interested in the audience, please get in touch with us. You know, we'll direct you through to Paul. And also when these are ready in the, did you say third quarter, Paul, or second quarter?
Yeah, it needs different elements of the open source products, if you like, and there's a good proportion of it that's already available. But you know, everybody's limited with the amount of resource that we have, so it's going to filter through in third quarter. It might filter through to fourth quarter, but yeah, certainly we can start
available through the FS network, won't we, Matthew, when they become available?
Yeah, I think what we'll, you know, I think there's a obvious case for a deeper dive here and really getting into it. So I think that's better in a face-to-face. So I think obviously Q3, I would like to, you know, invite our audience, come to the CSI office with IBM and spend half a day there and really get into the nitty-gritty and see that. So I think we will definitely make that invitation available with, you know, through this in the summer. For hopefully we'll be all out to meet and get to the offices from September onwards.
Absolutely.
Yeah.
I mean, one thing that we're finding is that, you know, we very much want to work with partners like yourself, CSI, and customers directly, rather than just create a product and put it out there to be used. And what we're doing with a lot of customers that are transitioning into this new offering, this new way of development, is by running workshops in the IBM garage. And this is a way that we can get together and come up with kind of design thinking ways of looking at problems or things that our customers would like to develop, but maybe it's the first time they're doing it or they would like some help. And these can start from maybe 2 or 3 hours to half a day as a discovery workshop, see perhaps what the goal or the objective is, and anything up to a couple of weeks to build an entire minimum viable product. And then, of course, we can help with proof of concepts, which could be deployed, I guess, on your CSI cloud, go on IBM Cloud, or even the customer's own premises, to actually, help them along the journey.
Excellent. Thank you very much, Paul. Is there any questions from anybody in the audience?
Yeah, we have a couple of questions. First one, what are the advantages of containers to availability?
Yeah, so containers, very smaller objects to work with, right? So I said it's a scale-out architecture. And you might typically have a workload running in 3 containers, which would be encompassed within pods across 3 physical servers. Now, Openshift is continually looking and gaining stats from all of those services. So if one of them should hang or stall or just fall off the edge of the world, then Openshift can go ahead and try and restart that container. If it's unable to restart it on that particular server for any reason, then it can try and restart it on a different server. So it will correct itself automatically. Also, when it comes to updates, we see with consolidation, we've packed more and more workloads onto servers, increasing utilization. It's been great, but when you do this, then you have to work with a lot more lines of business or customer suites to get downtime when you want to do an upgrade. But with containers, what you do is you would actually have a new container image created at the new version of code, and you deploy that and add that. So you might have 3 containers, you add a 4th running newer code. It's still load balanced, so it's still running across the road, and then you drop off the older versions. So actually, you get to update the systems without having any downtime. Also, you can have auto scaling, so you can actually set the system up so that it looks at the utilization, and when it perhaps is nearing capacity, or obviously before it gets to that stage, it actually increases the amount of containers available in that load balance scenario. So you don't have the problem of maybe it becoming overworked and performance issues from that side. So that increases availability too.
Another question. Thanks very much for that, Paul. For another one, why run this on IBM Power? What would be the benefits, you think?
Yes, I mean, from our perspective, as you know, Matthew, we're very technology agnostic here. But when we looked at this, the element that Paul spoke about there, that does all of the controlling and scaling and spinning up the containers and controlling the pods, which is the application architecture, that's all run by Kubernetes. And you really don't want that service to go down, especially if you've got lots of pods delivering applications out in public. So that initial control plane is actually high availability, but by putting it on the IBM Power platform, we also leverage the high availability of the hardware itself. So we've got a self-healing application architecture, and we've also got a high availability hardware platform. And we feel that gives us the rock solid capabilities that you need to run production workloads on Kubernetes with no threat that you're going to lose that control plane. So that was the main purpose for us. I'm sure there are other reasons that you've got, Paul, but that was from our perspective the reason why. Yeah,
I mean, co-locating with existing workloads when you're modernized is obviously key as well. You don't have to go out there and provision new infrastructure for it, right? You can do it right alongside. Very useful, especially for some of those organizations perhaps that are still doing internal billing on a per project basis. They've already paid for the hardware.
Sorry, and the flexibility for us as well, that you can have the controls in one place, but have the worker nodes, obviously, ideally via low latency. So we put it in a cloud exchange type environment, but having the worker nodes running in the individual clouds gives a lot of flexibility. And, as you mature in that kind of model, you can start to run those workloads wherever the cheapest cloud is to run those workloads. So it gives you that flexibility and optimization as well.
And the containers give you that portability. I mean, we showed the demonstration of using multiple clouds, but should prices increase in any one of those clouds, or maybe there be a security issue, then you can move those workloads around.
So it gives you exit protection as well, you know, within that exit strategy. Absolutely.
Well, I do have one. We have one last question. It says a solution requires multi-cloud hosting. How does OpenShift deal with this? So
OpenShift is a true enabler of develop once and deploy anywhere, and we kind of demonstrated that today, that we can move those around between the different clouds. Runs on practically any platform, you know, run on x86, run on Power, will even run on mainframe, runs on public and private clouds as well. We use Cloud Pak for MultiCloud Manager, which I showed you. So, you know, the great things about that is it's not one tool to look after virtual machines and another one to look at Azure containers, another one Amazon or so. This will look at all containers across multiple public clouds and also private clouds, and also the virtual machines too. And, you know, we've got different technology which allows us to do that. But that's a really, you know, good feature to bring it all in, because as companies start, you know, having many more clusters and many more clouds that they're working with, it's going to simplify that supportability very much. We use Cloud Automation Manager, which is based in using Terraform. We've also got Cloud Forms from Red Hat, which looks after all the public cloud infrastructure there. That's kind of been renamed as infrastructure management. And also we've got Red Hat Advanced Cluster Manager. So, you know, this will manage multiple clusters, whether that be a mixture of x86, Power and mainframe clusters as well. So the tooling is certainly there. As I said, you know, when I started looking at this 6 or 7 years ago, it was very, very early days, and it was more research and development really. Whereas now what OpenShift and Red Hat have done, they've used that upstream ecosystem. So they take that open source software, they harden it, they make it supportable, they make it enterprise ready, and then they just sell not licenses of the software itself, but they sell the subscription for support. And because of that, they're focused on support. And because of that, they offer great support. So this kind of solution is very much ready for organizations to take advantage of that.
And just a final word from me is that even though we've been talking predominantly about IBM Power and Linux today, apart from the control plane, everything else within the, you know, the piece that Paul has spoken about can also run on a Windows platform, Windows containers, etc. You know, the control plane needs to be on Linux or AIX or Power, but the actual control can control Microsoft Windows containers as well as Linux containers. Although there are problems with Windows containers around size, which anybody who's ever tried to deploy them will obviously know.
Yeah, I think, you know, there's tremendous, you know, agility and flexibility with the whole stack that's presented for this solution. It actually really does provide food for thought in terms of being able to, you know, to modernize the, you know, your whole process by adapting that flexibility. But, you know, it's really food for thought in terms of allowing the individual bank to take ownership of their innovation and not be reliant on their ISV core provider, which obviously is very powerful because obviously today people need to differentiate themselves and deliver new services fast. So
yeah, I mean, it detaches your business model from the roadmap of the ISV. You know, if you bring in support for crypto or whatever, you know, you need to have on your banking application, you can interface with that, provide those features effectively from the side, but it will still all be stored on that core, you know, that core database infrastructure.
Yeah, it's absolutely interesting. And you know, we will definitely send out the invites for a bums on seat session and get really into the nitty gritty, I think, of this. because I think it has a huge amount of value that we can explore a bit further in the autumn, and that'd be great. So I'd like to thank Paul for his time and all his efforts in preparing this. It's been really insightful and a really great presentation. Thank you very much, Paul.
It's been my pleasure. It's great to talk to you today.
I'd like to thank you, Paul, as well, on behalf of CSI for your continuing support. So thank you very much.
You're very welcome.
Right. Well, we look forward to seeing you in a month's time and talking about another new subject within the FS community. Appreciate. Thanks very much.
Bye all.